Hi everyone, we're going to find the limit if it exists, and these deal with one-sided limits. We're going to start with easy ones, and then we're going to end with absolute value ones. We have 6 here. And the first one we're going to do, and this is all algebraically, the limit as x approaches 5 from the right. So that means values like 5.1, 6, 7, as it gets closer and closer to 5 from the right. And that's the function is x minus 5 over x squared minus 25. And what I'm going to do is simplify this as x minus 5 times, over x minus 5 times x plus 5. And this cancels. We have a 1. So we take the limit as x approaches 5 from the right, and that's going to be 1 over x plus 5. And when you plug in the 5, you get 1 over 10. Okay, the next one is very similar. We have the limit as x approaches 2 from the right, and this is going to be 2 minus x over x squared minus 4. I'm going to rewrite this as x minus 2 like that. I'm just going to rewrite it. Because when I factor the denominator, these two cancel, and you get negative 1 over that. So take the limit as x approaches 2 from the right. So it gets closer and closer to 2 from the right side of negative 1 over x plus 2. That's going to give you negative 1/4. Okay, the next two we're going to do is the limit as x approaches negative 3 from the left. That means like if you put in values of negative 4, negative 3.1, and so forth, what would be the limit? So we have this one. Now if you think about it, as you put in negative 3, you're going to get a 0. So if you plug in negative 4, you would get negative 4 over 16 minus 9 is 7. If you plug in negative 5, you're going to get something. This decreases actually without bound. It never stops. So it decreases without bound. There's no boundaries. Therefore, the limit does not exist. L does not exist. All right, next one. We have the limit as x approaches 4 from the left. That would mean you'd have 3, 2, 1, plug in 0, things like that. So you have square root of x minus 2 over x minus 4. And what I'm going to do is go ahead and multiply by the conjugate in the numerator. So we have square root of x minus 2 for x minus 4. And I'm just going to multiply this by the conjugate, which is x square root of x plus 2. And I'm also going to do the denominator square root of x plus 2. And when you do that, you're going to get the limit as x approaches 4 from the left of x. And you square that, it's going to be x minus 4. So x minus 4, because we're just using the a squared minus b squared. You just square your a and your b. And the denominator is going to be x minus 4 times the square root of x plus 2. Now this cancels, so you get 1 over square root of x plus 2. You plug in 4, that's going to equal 1/4. So square root of 4 is 2. 2 plus 2 would give you the 4. The next two are absolute value. So the limit as x approaches 0 from the left of the absolute value of x over x. And basically what you need to know with absolute value is the absolute value of x equals, it's a piecewise defined function, equals x if x is greater than or equal to 0, equals negative x if x is less than or equal to 0. So basically, since we're coming from the left and it's 0 here, that means that the numerator is going to be negative x because it's going to be less than x. And I forgot to put this, we're coming from the left here, from the left. So that means it's negative x over x. And reduce that, that gives you negative 1. Okay, similarly, we have another one. We have the limit as x approaches 2 from the right. So that's going to be the absolute value of x minus 2 over x minus 2. Since we're going from the right, and that means we're going to have just x minus 2 on the top, and then x minus 2 on the denominator, and that equals 1. Okay? Thank you. Have a nice day. Bye-bye.